Didn't dawn on me at the time, but my little kite and key experiment a few years back really started people thinking about the phenomenon known as electricity. While I never dreamed back then that electric power would become a major source of energy for mankind the world over. But like most tools, electricity can be harmful if misused. We quickly discovered that our bodies are good conductors of electricity, and when we come in direct contact with current flow, we react with shock. But electric shock is only half of the danger. Electricity can also be converted into heat, which can set a variety of substances on fire. The more you understand about the characteristics of electric energy, the safer your working relationship will be. My famous kite experiment in 1752 first identified lightning as a form of static electricity. But man's earliest awareness of electricity has been traced back 2,500 years to the Greek civilization. Philosophers of the time discovered that they could pick up pieces of straw with an amber rod after rubbing it with a cloth. This early experiment with static electricity was really no more than an amusing parlor game to those who looked on. But the force that caused this to happen would someday serve to free mankind from the hard labor that binds him to this earth. Since the behavior of electricity is entirely predictable, a basic understanding of its characteristics will prepare you to deal with the hazards. Always maintain an attitude of safety when you're dealing with electricity or any powerful tool. Let's define some of the words we use to describe and measure electricity. We can think of electric power as water flowing through a pipe. Using this analogy, we can see that current is a word that refers to the total volume of water, or electricity, flowing past a certain point in a given length of time. Electrical current is measured in amperes. Voltage refers to the pressure in our electrical pipeline and is measured in volts. Resistance in any form retards the flow and is measured in ohms. The amount of power, or the units of electricity, are measured in watts. Any material which allows the flow of electricity to pass through is called a conductor. Any substance which impedes electrical flow is an insulator. Air is a good insulator. Water is a good conductor. And as we all know from experience, our bodies are also good conductors of electricity. Whether or not a substance is a good conductor or a good insulator is determined by the amount of free electrons it contains. Free electrons carry the current through the conductor. Things like wood, rubber, and glass have relatively few free electrons and make better insulators than conductors. Copper, silver, and aluminum, on the other hand, have many free electrons and conduct electricity easily. Resistance to the flow of electricity through a conductor is the means by which heat is produced from electric power. Free electrons moving through an electrical conductor create friction and give off heat as they strike the atoms in the material. Electric heaters work in this way. Remember, electricity is simply a form of energy that strictly obeys certain laws of behavior. To handle electricity safely, it is vital to know the sort of hazards it can pose and the means to eliminate or handle them safely. And in particular, we are talking about good old 110-volt AC power. Whether you're using it at home or at work, be aware that this standard everyday power source can be fatal. You don't have to be an electrician working with thousands of volts to be hurt or killed. So, to be specific, exactly where is the danger threshold in electric power? How much electricity does it take to put a person out of business? The answer to this may surprise you. Because contact with extremely low current, far below 1/10 of an ampere, can result in serious physical reaction and injury. And a 100-watt light bulb draws more current than that. Much more. Therefore, regardless of the voltage, 110, 220, 440, all electrical circuits must be considered hazardous. You must realize that contact with low voltages can result in injury or death. Shock is shock. Don't be misled. Any electric current must be treated with great respect. We have said that the amount and duration of current flow is the factor that causes injury in electric shock. Because power flow depends on voltage and resistance, you should be familiar with the things that affect your resistance to electricity. Your skin offers some insulation against electric current, and it has been discovered that dry skin offers appreciably greater resistance to electric shock than does wet skin. Wet skin in contact with very low current flows can produce injurious or lethal results. However, this should not give you the idea that dry skin will provide immunity from electric shock. It won't. Under all circumstances, avoid contact with exposed electrical current. Because so many people are unaware of the dangers of low voltage, it is responsible for more deaths and injuries than high voltage. If you see that another person has received an electric shock, you should know what to do to help him recover. Electric shock is an extremely serious emergency which can result in stoppage of the breath and fibrillation of the heart. Learn the proper first aid procedures, and if an emergency arises, prompt action on your part may save the life of a coworker or a member of your family. In all cases, give the victim professional medical care as soon as possible. But remember, if the victim is still in touch with the current source, do not touch his body yourself, or you too will be shocked. Instead, get the victim's body away from the current using some non-conductive material like a dry board or rope. Or, better still, pull the plug, shut off the current, or throw the breaker to stop the flow of electricity to the victim. Only then can you begin your first aid procedure. Current flow is not always of sufficient strength or duration to stop the breathing or interfere with the heart or nervous system. But there are other hazards to consider when coming into contact with electric current. Painful burns and blisters from electricity are usually deep. Mechanical injuries from electrical equipment may be caused by unexpected motion, such as the accidental starting of motors which drive machines. Electrical lockout procedures are meant to protect workmen who are involved in the maintenance of electrically driven equipment. But lockout theory does no good at all unless followed precisely at all times. Falls from one level to another are secondary hazards of electricity. If a workman receives an electric shock which results in muscle contraction, he could easily lose his balance and his footing. Let's look now at some safety points you should keep in mind in order to minimize the chance of accidents involving electricity. When using electric-powered hand tools like drills or saws, always disconnect power before putting a new drill bit or a saw blade in the tool. Take the time. It's worth it. And check the condition of the power tool to be sure that it's safe to use. Look for cracks and wear on the power cord and the tool housing. A damaged cord is no longer water resistant. The insulation can absorb water, resulting in a short circuit. If wires are exposed through worn spots in insulation, not only could someone in contact be shocked, but arcing would create a fire hazard. If defects are discovered, don't attempt any makeshift repairs. Report the problem to a supervisor or someone in charge of maintenance.
I have a drill here that's shocking me when I use it. I notice the case is cracked. Could you
I think we can take care of that. Get that oven over there and use it, and we'll replace the case on this one.
All right. Thank you.
Remember, do not use electric hand tools in wet locations. Only use power tools that are grounded or double insulated. The use of a ground wire, the third prong, protects the operator in the event a short circuit develops inside the tool. The ground wire forms a continuous path from the equipment through the receptacle to the ground. The current is drained from the metal frame of the tool through the wire and not through the operator's body. When using extension cords for any reason, be careful to place them along a path of safety, not like this, for example. Protect the cords from sharp edges, heat and oil, or solvents that might damage or soften insulation. Cords that are run through doorways create a safety hazard at the pinch point. When it's time to remove an extension cord from an electrical outlet, pull the plug out. Don't jerk the cord from across the shop. This habit will eventually damage the connection or the insulation. When selecting the cord you will use, remember, just because it's long enough doesn't mean it's the right electrical extension for the job. Consider the load capacity compared to the load you are expecting it to carry. The length of the extension you are running also affects the requirements of the wire. If you are in doubt about the suitability of an extension, ask an electrician. Protect the extension cord from plant traffic which could damage it. Boards or rubber cord protectors can be arranged to form a protective bridge. It is important to remember that electrical standards and requirements differ from plant to plant, and often change in the different areas of the same plant. By electrical requirements, we mean primarily the relative potential for explosion from an electric spark. In some work areas, the electrical precautions must be very strict due to the potentially volatile atmosphere. For the same reasons you wouldn't smoke while filling the gas tank of your car, you also guard against electric sparks in what are known as explosion-proof areas. Learn where these areas exist, and be sure you know the rules that apply. Flammable gases, vapors, dusts, and liquids can be ignited and set afire from sparks originating in electric switches, connections, tools, and fittings. Here are a couple of final points for handling electricity safely. During construction or maintenance operations which require temporary electric wiring, observe all normal precautions. Temporary wiring should not mean poor wiring. An electric shock victim does not care that he feels that current from a permanent fixture or a switch box just nailed to a post yesterday. One is just as hazardous as the other. Good housekeeping practices apply in the temporary applications as well. Poor insulation and overloading of available circuitry are common problems that cause accidents when temporary wiring is in use. And if an electrical fire develops, use the proper type of extinguisher on the wiring that is ablaze. Chemical extinguishers are for this purpose. Do not use foam or water on electrical wiring. Before sawing, nailing, or drilling, check to be sure that there are no electric wires in your way. Electricity is a powerful tool, one that you have become accustomed to using every day. When you use an electrical appliance, you apply electricity. But only when people come in contact with electricity in its raw form are we reminded that there's more to that outlet than a light bill at the end of the month. The fast-moving electrons in a hot lead are not visible to the eye, but you can feel the current instantly. The power is there, so learn to treat it with the respect it deserves.